Hello guys and welcome back. So now we're going to take a look at creating this look here that requires environment lighting and point lights. And one of the main drawbacks of the micro polygon or this depth map shadow is that it cannot simulate shadowing from a infinite source or a dome-like source. So for example, in an environment light you have lights coming from everywhere, so it's hard or impossible to mimic that using the depth map shadow. Depth map shadow only works when you have a specific light looking at a specific angle. And in the case of a point light, again, the light is coming from 360 degrees, so it's hard to narrow down which part to compute depth map shadow for. There is techniques that involves generating 6 maps and dividing the point lights into 6 different spotlights, each covering one side of a cube, but we're not going to do that. We're going to use ray tracing in this case. And the micro polygon, if we go here, the micro polygon by default does not handle ray tracing at all. So to basically turn on ray tracing in micro polygon, we're going to use the ray tracing algorithm, and that's what this is. This is micro polygon with the ray tracing feature enabled. So I'm going to go back and we're going to create 2 new lights. The first one is an environment light, and don't worry about the light types and everything. We're going to have a separate video, or the cable scene, the statue with the cables. We're going to cover all the light types and go over the settings in more details. So I'm going to set this to have a blue tint, and I'm going to create another light, and it's going to be a point light. I'm going to place it at the center, something like that, and set the intensity to 2000, give it an orange tint. And one thing I'd like to do is to visualize the intensity. We can use, let me hide the points, I'm going to use a grid. And if we turn on the normal lighting, we can see the result here. I had these lights on, they were contributing to the viewport, and I turned this off to turn off the viewport contribution, but they still render fine. So now we're only looking at the point lights result, and then under attenuation I can lower the range, or how far this light reaches. So I'm going to turn this on, I'm going to lower it to 40, lower, cool. So that's the range, and then we can also specify how the light decays if we didn't like this. And what I like to do is I like to copy this and paste it here in the ramp end, and we can specify how the light decays. Now this doesn't get reflected in the OpenGL viewer, but we're going to see it in the render. I'm going to call this center. This is environment light, and we don't need the grid. I'm going to copy the particles, and I'm going to call this particle look trace. And I don't want to use the colors, so I'm going to copy the shader and just turn off the colors and the transparency as well. So no more transparency, and the colors, I just need white. Okay, let's go back here. Let's assign this look. And in the render, I'm going to copy this, call this ray tracing. And we can include specific objects instead of that. So I'm going to include this and the lights as well, the environment light and the center. And let's leave this at micro polygon first. I'm going to hit render. And it's just recomputing the SOPs because we copied the node. The settings are quite high at the moment. So let's load in the LUT. Cool. So this is the lighting from the Omni as well as the environment light. But if it may not be very clear here, but once we do once we turn on the shadowing or the ray tracing, it's going to be much more visible that this doesn't have shadows. But it looks cool, so it really depends on the look that you're trying to achieve. And you can see here the environment light is working as well. Okay, so let's let this render, and I'm going to change this to ray tracing. I'm going to leave the settings the same. I'm going to hit render again. Okay, I'm going to cancel this. And this is pretty high. 16 by 16 is pretty high. And that's the difference. Now the shadows are being computed. We're getting ray traced shadow from the environment as well as the point light. You can see the difference here, which is very, very cool. I'm going to lower the intensity of the center light. It's quite bright. Set this to 400. And for the environment light, I'm going to leave it as is, but in here we can turn on AUVs that will allow us to view each light result in a separate AUV. So I'm going to go under Images, Extra Planes, add a new AUV. This is where we create them, and I'm going to say Combined Lighting per Light. I want to add this. Okay, let's lower the settings a bit. 8, and let's hit render. And this is pretty much the ray traced look. If you need realistic shadow or ray traced shadows from point light and environment light, this is the way to go. Now ray tracing is still faster in some cases compared to PBR, and we're not going to use PBR at the moment. The result will be similar to this. It's just different algorithm, but it will be able to handle ray traced shadows as well nicely. Let's look at the light AUVs. So this is the environment light. I'm gonna gain it up. You see we're getting some kind of environment lighting with shadowings and everything. And then the center, this is the center. Cool. So it took 40 seconds. Let's go. We have another camera that is closer. Yeah, this one. So let's do a test with this set to 1414. Let's see the. Okay, so the shutter time is 2 times is 1 basically. It's 2 times bigger. So the motion blur is going to be 2 times more than the normal. And everything's the same. I'm going to change the camera to 2. Let's hit render. It's going to be slower, obviously, but I think it's worth taking a look at. Now with the PBR, we can use this as well to render a similar look to this, using even the principled shader only as a diffuse material. But that could be slower, especially when you have extreme motion blurs like this. Ray tracing is a better choice in these cases. Let's take a look at the environment light. Cool. And the center. We're still using the same isotropic shader. So one more thing I'm going to do, I'm going to go back to the Chem 1. I want to do another render. Actually, yeah. Let's go to Chem 1, select it. The shutter time for Chem 1 is also 1, so we were getting 2 times the amount of motion blur that we should have by default. For this, I'm going to go inside the shader and connect the colors back to the diffuse. And we were getting this color. Let's go back to the out, change this. I'm going to lower the settings a bit, and we'll wait for this to finish. Very, very cool. So yeah, there's tons of ideas in terms of look, what we can do with these points and how we can render them, different rendering algorithms that we can use, different lights, and it really depends on what you guys want to achieve with these effects. I'm gonna wait for this to finish. I really like it. Cool. Okay, let's do our last render for this, and I think the next project we're gonna start creating the cables. Let me check. This one is using a very similar look to the blue version. It just I used a different ramp of orange based on the velocity speed. So the faster it is, the brighter it gets. And it's exactly the same shader. This one I used a point light with a micro polygon, but it's not computing shadows or anything, just causing this. I believe I had a spotlight from here and aiming at these two guys, and then this effect is fake. I did it. This glow here is basically this version overlaid on top of this, just using color correction, and I think that's pretty much it in terms of look with all these guys. Yep. So this is the version with the color on. And it's quite noisy. The reason for that is because there's a lot of variation in the colors and the particles themselves, not primarily from the render. Cool. Thank you guys for watching, and see you in the next video. Bye bye.